In this video, we're going to talk about percentiles and quartiles. So all of our percentiles, quartiles, quantiles, they're all telling you about the same thing. It's just slightly different ways to talk about it. They all provide information about the spread of a random variable. Now, we already learned about how to use standard deviation or variance to talk about the spread. This is just a different way to do it. You also see this a lot when you do testing. Like if you were to take, say, the SAT test, you get your results back as a percentile, or when I take my baby into the doctor, they gave me the weight and height as a percentile. So these are very common in practice. Okay. By definition, the pth quantile is the value of x for which f of x equals p, or it's the probability that we have some number less than or equal to x. It's also referred to as the p times 100th percentile. So in other words, the 0.25 and 0.75 quantiles would be the 25th and 75th percentiles. Now, you should remember from other classes that you have quartiles, which your quartiles are like your bottom 25%, bottom 75%, etc. of your data. The quartiles mean you divide your data into 4 sections, so 0.25, 0.5, 0.75. So those are your quantiles. The median is divide your data in half, so that would be the 0.5 quantile or the 50th percentile, or it would be the value for which the CDF is equal to 0.5. So with that in mind, let's try this. So example 78, a PDF is f of x equals 3 out of 1,000 x squared. X can go from 0 to 10, otherwise it's just going to be 0. Okay. First, find the CDF. The CDF is always easier to use when working with percentiles. So to find the CDF, we know we have to integrate. When you integrate, you start at the bottom bound, which is 0, and integrate to your actual variable of interest. You integrate the PDF. So 3 out of 1,000. Now, instead of an x, we're going to put in a dummy variable, which is usually t. So we'll do t squared dt. When I integrate this, okay, we'll have 3 out of 1,000 times t, raise the power by 1, so to a 3, divide by your new power, so those 3's cancel, and we get, oh, sorry, I forgot my limits, evaluated from x to 0. Those 3's cancel, so we're going to have x to the third over 1,000 minus 0 to the third over 1,000, which is just x cubed out of 1,000. Now remember, your bounds always stay the same, so our bounds will be from 0 to 10. So what is the median? Median is where we have half of the data below, half above, or our CDF would be equal to 0.5. Okay. So we'll say x cubed over 1,000 equals 0.5 because we want to know when that happens. And we will solve for x. Okay. I'm not going to actually do that. You should be able to do that by now. We get x equals 7.937. And that is our median. So half the data is below 7.97, half the data is above 7.937. How would you find the 0.37th quantile? It's the exact same thing. You want to have 0.37% of the data below it, so you just look for where is the CDF equal to 0.37. So x cubed over 1,000 equals 0.37. Solve for x. So x equals 7.179. So you can say that the 0.37 quantile is 7.179. Or also you could say, if you wanted to, the 37th percentile is again the 7.179. And again, this just means that 37% of the data is less than 7.179.